Chromatography is a method by which a mixture is separated by distributing its component between two phases, which is the stationary phase and mobile phase. The stationary phase remains fixed in place, while the mobile phase carry the component of the mixture through the medium being used. The stationary phase acts as a constraint on many of the component in mixture, slowing them down to move slower than mobile phase. Useful chromatography in lab is creating vaccination. In example, chromatography useful in determining which antibody fight various disease and virus. Secondly, drug testing. In example, chromatography can accurately identify substance within the bloodstream.
Hi and Assalamualaikum. My name is Nur Aisyah Farhana binti Muhammad Sabri. Today, I will explain about theory for our topic. First and foremost, what is TLC? Thin layer chromatography, TLC, is a type of chromatography in which the stationary phase is a thin layer of adsorbent particles attached to a solid plate. A small amount of sample is applied near the bottom of the plate, and the plate is placed in the solvent, which is the mobile phase. This solvent is drawn up by capillary action. So from this capillary action, separation occurs as each components being different in chemical and physical properties. So it will interact with the stationary phase and mobile phase to a different degree, creating the individual bands on the plate. So from this picture, we can see that the TLC plate is the stationary phase and the solvent is the mobile phase. So let's move on to the next slide. So from here, we can see that the TLC plate that have been spotted with the sample at the baseline, and also the TLC plate has been soaked with the solvent. So the mixture of the component are moving at different rates because this TLC plate have adsorbent material, which is aluminium oxide or silica. So after the TLC plates have been dry, the sample's components are then identified by comparing their retardation factor RF values to those who have been separated with standards. TLC is widely used by many industries and researchers fields, including pharmaceuticals, clinical testing, environmental toxicology, food, water, and pesticide analysis, and cosmetic. Typical application of TLC include: first, analysis of drug residues and antibiotics in food and environmental samples. Second, identification and quantification of colors, ingredients, preservative, and sweetening agents in food and cosmetic products. Third, quality control and purity testing of pharmaceutical formulation. Fourth, rapid high throughput screening pure to HPLC. And lastly, examination of chemical reaction for completion.
Okay, now we continue with methodology. Preparation for extraction of the leaf which is sample. Number 1, about 15 to 20 pieces of fresh leaf are obtained and cut into a smaller pieces. The leaf are ground together with 15 ml of acetone and 10 ml of petroleum ether and a spatula of CaCO3 using a pestle and molder. The mixture is mixed well. Number 2, the liquid extract is poured or transferred into a small beaker. 2 spatula tips of anhydrous Na2SO4 are added to dry the water moisture. Number 3, the mixture is filtered into a 10 ml of beaker. Number 4, if the filter extract is still too dilute, the extract is concentrated by immersing the beaker into a boiling water until the final volume is about 2 until 3 ml. Okay, next, preparation of developing solvent. Number 1, the mobile phase which is developing solvent is prepared by mixing 10 ml of petroleum, 1 ml of isopropyl. Okay, now I will proceed in application of the extract to the TLC plate. Number 1, with a pencil, a line is drawn approximately 1.5 cm from the bottom of the plate. Number 2, using a capillary tube, the leaf extract is deposited along the line drawn. The process is repeat until a very dark green line is obtained to the plate. Next, developing the TLC plate. Number 1, the load TLC plate is carefully placed into the TLC jar containing the developing solvent. Number 2, it is ensured that the level of the solvent is below the line was drawn. Number 3, the TLC jar is covered and left undisturbed. Number 4, when the solvent font has reached 3/4 of the length of the plate, the position of the solvent point is marked and the TLC plate is removed from the developing jar.
Oh, I didn't see you there. Next, I will be explaining about example of results. Overall, thin layer chromatography or TLC can be a valuable tool for exploring the chemistry of plant pigments. While TLC is more commonly used in professional and educational settings, it does have applications in daily life, particularly for educational, hobby, and practical uses. What are these practical uses, you might ask? Well, now let's explore the applications TLC offers in daily life. First, those who are interested in natural dyeing processes can use TLC to understand the composition of plant-based dyes. TLC helps identify the different pigments present in plant extracts. This is essential for understanding the composition of natural dyes and their potential applications such as in clothing, food coloring, and makeup. Other than that, TLC chromatography plays a crucial role in ensuring the quality of herbal medicine. Herbal medicine practitioners might use TLC to verify the presence and concentrations of active compounds in herbal preparations, ensuring the consistency and efficacy in traditional medicine. Lastly, botanists or plant enthusiasts can use TLC to study and compare pigment compositions of different plants. TLC helps us to identify and separate various phytochemicals, such as secondary metabolites in plant extracts. For example, alkaloids, flavonoids, and phenolic compounds.
For the conclusion for this topic, which is separation of the plant pigment through thin layer chromatography, chromatography is an effective technique for separation and identifying the different pigment present in plant leaf. It also provides a rapid and effective separation, often yielding result within a minute. Secondly, it is a useful technique for determining the purity of substance and identifying contaminant or impurity in sample. In addition, thin layer chromatography (TLC) has many applications across various fields, for example, pharmaceutical, biochemistry, food industry, and forensic science. For example, in forensic science, TLC is used in forensic laboratories to identify drugs and toxins in biological samples, such as blood and urine.